Our next vocabulary video is from 1-3, measuring segments. Okay. All right, our first postulate is called the Ruler Postulate. Every point on a line can be paired with a real number. This makes a one-to-one correspondence between the points on the line and the real numbers. The real number that corresponds to the point is called the coordinate point. If you remember, we've seen coordinate points before on an XY axis, like 1, 2, 1 to the right, 2 up. Okay, so it's the same thing, it's just linear, it's just on a line now. Okay, so A could be 1, B could be 2. Alright, so when we want to find the distance between 2 points, we always find the difference. Okay, and remember, distance is always positive. Always. You'll never have a negative distance. If you do, you did something wrong. Okay, so here we're going to find ST. Now you notice the S and the T are together. Okay, there's no line above it. Okay, so even though it is talking about from S to T, okay, and it is a segment, when there's no line above the ST, you're looking for a number. Okay, so they want to know the distance from S to T. Couple things you could do. First thing is count. But if you're going to count, you have to be very careful because these units go by twos. Okay, so from S to T, so you go 2, 4, 6, 8, 10, 12. So the distance from S to T is 12. Okay, another way you could do it is you take the difference. Okay, and when I say it's always positive, what you should remember is the word absolute value. Okay, absolute value, remember, is the distance something is from 0. Okay, it's also when you have positives. So the distance from S to T, you can go -4, okay, minus 8. That gives you the absolute value of -12, which is a positive 12. Okay, so you can count or you can take the difference of the 2 points. Next one is postulate 1-6, segment addition postulate. If there are 3 points, okay, in this case A, B, and C, okay, which are right there, okay, are collinear. Remember, collinear means they're in a straight line. So A, B, and C are in a straight line, and B is between A and C. Then you can take AB plus BC, okay, and that gives you the entire segment. Okay, it's called segment addition postulate. Okay. Next one, when numerical expressions have the same value, you say they're equal. We're really used to saying equal. X equals 2, 2 equals 2. Okay. Okay. In geometry, if 2 segments have the same length, they're called congruent. Okay, congruent segments. Okay, so there's a symbol for congruent. Okay, but congruent means equal. Okay, so this means that if AB is equal to CD, then line segment AB is congruent to line segment CD. And if you remember in our past video, this AB and CD, you notice, don't have a line above them, so those are actual numbers. So that would be 4 equals 4. Okay, those are actual numbers. Here, we're actually talking about a line segment. It's not necessarily a number. So, like in the figure, AB, okay, here, right, is congruent to CD. Okay, so I don't care about the numbers. I'm just saying they're congruent. Okay, and you can also go the other way. If 2 segments are congruent, then I know they're equal. Okay, so AB is congruent to CD. So if AB equals 7, I know that CD equals 7. Okay, so basically, it's saying that congruence and equal are the same thing. Okay, it's just know when to use congruent, when to use equal. Okay, now I already did this, but you can mark segments alike to show they are congruent. Okay, remember I put 1 mark here for showing that AB and CD are congruent. Okay, here AD, if I had AD as 2 marks and AD is congruent to BC, I would mark BC with 2 marks. Okay, and that's how we mark congruent segments. Alright, last thing, midpoint. Midpoint of a segment is the point that divides the segment into 2 congruent segments. B is the midpoint of AC. So you notice AC is a segment, okay, and B is the midpoint. So you see how we marked AB is congruent to AC, okay, because B is the midpoint. Alright, segment bisector is a point, line, ray, or other segment that intersects a segment at its midpoint. So line L here, okay, intersects, which means to cross, segment AC at B, which is the midpoint. Okay, so then it bisects the segment. The point, line, or ray segment is called a segment bisector. Okay, so line L is a segment bisector of AC.